So now we are going to discuss about the color and magnetic properties of transition metals. Color and magnetic properties of transition elements. Now, moving on to the color. So, to have this color, the transition metals should have unpaired electron, right? Whoever having unpaired electrons, they will show color. Why a substance shows color? A substance appears colored when it absorbs light from the visible region of the electromagnetic spectrum. That is from visible region of the electromagnetic spectrum, visible region of the electromagnetic spectrum. When a substance absorbs lights from the visible region of the electromagnetic spectrum, right, it shows color because it emits exactly the complementary color of the absorbing light. For example, if you are considering Cu plus 2, this copper ion absorbs wavelength that corresponds to red light. Wavelength that corresponds to red light, and which emits the wavelength which corresponds to blue light, in the electromagnetic spectrum. How to know these particular colors, which ion absorbs which color and what type of color it will reflect, that one we can understand from the wheel diagram, color wheel diagram. Color wheel diagram we can write from by using Webber. In this one we will not include I. So here if you are cutting like this, you will get V, I is not there, B, G, Y, O, R. From this one we can get the complementary colors. For example, if you are looking into the green color, right, its complementary color is red. If you are looking into the blue color, its complementary color is orange. If you are looking into the violet color, its complementary color is going to be the yellow. So here this will give you the outcome of the complementary colors for any metals which are absorbing and what color it will transmit. Right? In the visible region means what is the visible region? 4000 angstroms to 7000 angstroms. In this visible region, any substance will absorb light and that will transmit the complementary light color, right? Complementary color, it will give the, it will transmit the complementary color. Now moving on to the electron. The presence of unpaired electron will give color. Why? The presence of unpaired electron, how it is going to give color? The presence of unpaired electron undergoes transition between low level to higher energy level of the d orbital. Already we know that d orbital will undergo splitting, right? In this one, the one who is having low energy, the electron will undergo transition from lower energy to higher energy level. During this promotion, it needs some energy, right? That will absorb from visible region, right? So why the color will come? When the unpaired electron is present in the d orbital, that time only it will give color. How it will give color? It will undergo transition from lower energy level to higher energy level. Why? Because that time it absorbs energy from visible region. and obviously it will give the complementary color. Complementary the color it will give. So in this way any substance will be colored. Now we will see what our D block elements will be. Transition elements will give you color. Looking at here, for example, if you are considering D0, that is scandium plus 3 configuration, D0, as there are no unpaired electrons, these are going to be colorless. Why these are colorless? Because there are no unpaired electrons. Scandium, titanium. If you are considering this one, the electron configuration is going to be D1. Obviously, it is going to give you a color pink. Why it is going to give you a color pink? Because having one electron. So how to know which colors will be coming? That is based on the experiment. How many electrons present in the system? Based on that, it will give colors based on the transitions undergoing. We cannot predict directly by based on electrons which color will come, because that will be based on the experiment. So D1 will give you pink color. If you are considering scandium, titanium and then vanadium plus 3, it is going to be D2 and it is going to be green in color, right? So vanadium in plus 3, that is D2, and it will have 2 unpaired electrons, and so it is going to give you D green color. Scandium, titanium, vanadium and chromium, manganese, iron. If you are considering all these things, these are going to have D3, D4 and D5, right? And D3, D4, D5, this is going to have violet, violet and yellow color, right? So based on the electrons, the color is varying. 1 electron pink, 2 electrons green, 3 electrons violet, 4 violet, 5 yellow. Now moving on to 6, 7, 8, 9, 10. So these are the colors of the transition elements which are having this type of number of electrons in the D shell. If you are considering B6, right, that is, I am going to start from manganese plus 2. Scandium, titanium, vanadium, chromium, manganese, that is D5S2, right? If you are removing 2 electrons, right, D0, D1, D2, D3, D4, D5. If you are considering D6S2, iron, manganese, it is going to be D5S2. If you are considering this color, right, it is going to be it is going to have D5 again. So manganese plus 2 is going to have D5. So its D5 is going to have which color? So manganese, iron, I am going to take plus 2, cobalt, nickel, copper, zinc. So let me write the electronic configurations first. D6, D7, D8, D9 and D10. Right? And it is going to have pink, green, again pink, again green and blue and colorless. So if we can observe very clearly from this particular table, it is going to give you the overall colors of all the D block elements, that is 3D series. These are transition elements. 3D series. We can see here from the colors to colorless. What we can note it from here is very clear. It is clear that if there are no valence electrons from D0 and D10, there are no valence electrons, and hence the color is going to be colorless. Moving on to D1, D2, D3, D4, D5 and remaining all are colored due to presence of D electrons that are unpaired electrons. In this way we can understand the colors of the transition elements. Now we are going to discuss about magnetic properties. Magnetic properties of transition elements. Magnetic properties. Right? Now magnetic properties. So there are two type of magnetic properties. Broadly we can divide into two types. One is paramagnetic, other is diamagnetic. Paramagnetic substances and diamagnetic substances. Paramagnetic substances are the substances in which it will be, the substances will be weakly repelled by the magnetic field. The substances which weakly repelled by the magnetic field will come under paramagnetic. The substances which are completely repelled by the magnetic field are called, completely repelled by magnetic field are going to be diamagnetic, right? And which one will have this type of paramagnetic? The substances which are having unpaired electron will possess paramagnetic nature. Unpaired electron should be there in the substances, then they will have this type of paramagnetic nature. If there are no unpaired electrons, then they will possess this type of paramagnetic nature. No unpaired electrons is the criteria for this one to be diamagnetic. If there are unpaired electrons, they will show paramagnetic. Now we are going to discuss about paramagnetic and diamagnetic nature of all the d block elements we are going to see. Right? Now, presence of unpaired electron. Actually, every material, every electron act like a tiny magnet, right? And this magnetic property we are going to calculate by using a formula called spin magnetic momentum. So, right, spin magnetic momentum, we are going to calculate the paramagnetic nature by using a formula called spin only formula. By using spin only magnetic momentum formula, we are going to calculate magnetic momentum, spin only magnetic moment, right? So what is this formula? In this one, this is going to indicate the magnetic moment. Here it is magnetic moment, and it is going to be indicated with a formula called 4s into s plus 1, where s is equal to spin of electron. But this is not the final formula from which we are going to derive one more formula. Here s is equal to n by 2, right? S is equal to how much? N by 2. So if you are considering n by 2, the formula will become like this. We can see here very clearly, if you are substituting this n by 2 there, this is going to become 4 into n by 2, right? 4 into n by 2 into 1 by n by 2 plus 1. If you are again doing the calculation, it will become how much? 2n into n plus 2 by 2, right? It's all over root actually. Everything will get cancelled and the formula will become n into n plus 2. So what is n here? The units are Bohr magnetons. Units are Bm means Bohr magnetons. Right? What is n here? N is equal to number of unpaired electrons. Number of unpaired electrons. Now we are going to see the magnetic calculation of magnetic moment of all the d block elements from d0 to d10, right? So this is the formula to calculate magnetic moment from the spin only magnetic momentum formula, right? Now, so the formula, I am going to use this formula, mu is equal to root over n into n plus 2 Bohr magnetons, right? Now, going to calculate the magnetic momentum for d0. As there are no unpaired electrons, the magnetic momentum is going to be 0. Why? Because there are no unpaired electrons. Because n is equal to 0, obviously mu will become 0. Now d1. d1 means how much is going to be? Root over 1 into 1 plus 2. Same way, d2. Root over 2 into 2 plus 2. d3. The same way we have to enter everywhere unpaired electrons. 3 into 3 plus 2. d4. Root over 4 into 4 plus 2. We can understand clearly how we are writing this one from the formula 5 into 5 plus 2. So, which is going to be diamagnetic here? The one who is not having unpaired electrons. The same way, let me write here, then we can calculate all together at a time actually. D8, D9, D10. Now here it is D6, D7, D8, D9, D10. It is going to be based on low spin and high spin. Why? Because based on low spin and high spin, the number of electrons will be varied. Already we have seen that arrangement of electron configuration in low spin and high spin separately. Right? So we will calculate this one for directly low spin one time and for high spin one time. Right? So here these are the answers 1.73 because root over 3 will come as 1.73, root over we can see here 4 2s are 8, root over 8 will give you 2.84, like that if you are doing checking this one, right. So it's almost equal to 26, 26 will come as root 26 is come as 5.92, like this will come. Now I am going to write here directly high spin configuration in which the number of unpaired electrons is going to be how many? Obviously it's going to be how many if you are filling this one, right? 1, 2, 3, 4, 5. So till D5 we can go directly. D6 is going to be here. How many unpaired electrons is going to have? 4. Root 4 into 4 plus 2. Exactly it will come as like this. How much? 4.90. Root over, now 7th electron will come enter here. 7th electron entering here means how much? 7th electron entering here means it is going to be how many electrons? 3 into 3 plus 2. Right? So again it is going to be 3.87. 8th electron is going to enter. How much? 8th electron means 2 more electrons are there. 2 into 2 plus 2. It is going to be how much? 2.84. Now again 1 more electron is going to enter. Now 1 into 1 plus 2. How much? 1.73. Because D10 is going to be completely filled, it is going to be 0. So these all will have Bohr magnetons or units. So in this way you can calculate the Bohr magnetons for all the electronic configuration based on this one, right. This is for the D0 to D10 electronic configuration.